Hey guys, today we are getting into the angle addition postulate. Remember that we talked about this segment addition postulate a few days ago, where we add up two smaller pieces of a segment and get the total length of the larger segment. The angle addition postulate is going to work very similarly. So first off, we need to define what an angle is. And an angle is just two different rays with the same endpoint. Two different rays with the same endpoint. So if I draw an angle in, and I would encourage you to use your straight edge here. Here's my angle. I'm going to call it X here, Z here, and I'm going to call this point Y. So point Y is our vertex. Then the two sides are here. So these are the sides of our angle. Our angle is made up of two rays, as our definition tells us. So those two rays are YX. Remember that we have to go from end point to arrow. And then YZ, two rays with the same end point, point Y, that's also our vertex. We can name this angle in three different ways. We can name it angle Y, just name it by the vertex. Or we can name it with all three letters that we see there. So to do that, we're going to kind of travel around the angle. So I'm going to start at point X, then go to the vertex Y, and then point Z. So angle, notice that little like less than symbol is our angle symbol. X, Y, Z. Again, order doesn't matter here, so I could also say Z, Y, X. Name the three different angles that you see in example 1. That's not naming it in three different ways. That's naming the three different angles you see. Try that right now. Okay, so the three angles we see are this big angle right here, which is angle A, B, D. The angle that makes up the top half here, which is angle A, B, C, and the angle that makes up the bottom half here, which is angle C, B, D. Notice in all of these, B is in the middle because it's the vertex. And again, order doesn't matter, so you could have flipped those and had DBA, CBA, or DBC. Okay, so what we're looking at now is the protractor postulate, and there's a protractor already on your paper. This is showing you how to line up your protractor. So we line it up with 0 or 180 right here, and then we look to the other side here to see where this lies. Now, since this side over here is the beginning, here's our 0, so we are going to use the bottom set of numbers. So if I look to the bottom, I'm somewhere between 110 and 120 degrees. And if you look very closely, it looks like this one is at about 113 degrees. So the measure of angle AOB is 113 degrees. Just like we don't put the bar on top when we're talking measuring line segments, we put this M there to show the measure. I would like for you to find the measure of the angle you see there on your paper and then to draw a 150-degree angle. We'll go over those two together in class to make sure you are getting it. But pause your video, try those on your own. All right, there are 4 types of angles. Use your straight edge here. Again, I'm going to quickly sketch them out, but please use your straight edge. So you've probably heard of these types of angles. We have an acute angle. An acute angle is an angle that is smaller than 90 degrees, but it's also bigger than 0 degrees. So 0 degrees is less than the measure of angle A is less than 90 degrees. So then over here I'm going to sketch an acute angle. And I'm going to call my vertex A. So angle A is between 0 and 90 degrees. Then we also have an obtuse angle. We know that an obtuse angle is bigger than 90 degrees, but it's also smaller than 180 degrees. So here's my sketch of my obtuse angle. We also have another option, a right angle, that is exactly equal to 90 degrees. So we draw our picture with our right angle. The last option may not have been one that has occurred to you before, but it is called a straight angle. So obtuse stops just before 180 degrees, but a straight angle is exactly 180 degrees. So it just looks like a line. So here's my vertex A. It equals 180 degrees. Okay, so our angle addition postulate tells us that we add the 2 smaller angles together to make the larger angle. So if point P is in the interior, if it's inside angle RST, then the measure of angle RST is equal to the sum of the measures of those 2 smaller angles. So the measure of angle RSP is right here, and angle PST. So just like when we talked about our segment addition postulate, we're adding up the 2 smaller pieces to equal the bigger piece. So if we know the angle of GFJ, this whole thing, is 155 degrees, we need to find the 2 smaller angles. So 4x plus 4 plus 4x minus 1, those are the 2 pieces. That equals our total of 155. Now, since these are on the same side, I'm combining like terms. So 4x plus 4x gives me 8x. And then plus 4 minus 1 is 3 equals 155. Then I'm going to subtract 3 from both sides. So 8x equals 152. Going to divide by 8. On both sides, and 152 divided by 8 gives us 19. However, that's not what we're looking for. We need to find the measure of angle GFH. So I'm plugging in GFH is 4x plus 4. So 4 times 19 plus 4. And we get 80 degrees. We also need to find the measure of angle HFJ, which was 4x minus 1. So 4 times 19 minus 1. So 4 times 19 minus 1 is 75 degrees. You add those up, they should give you that total of 155 degrees. Okay, the next piece we're talking about are congruent angles. So we talked about congruent segments. Congruent angles are two angles that have the same measure. So two angles that have the same measure. So when we write this, if we want to say that two angles are equal to each other, we say the measure of angle A equals the measure of angle B. So when we say they're equal, we put the measure there, we put the M in front. If we say they're congruent, though, we don't put that M in front. So angle A is congruent to angle B. Okay, identify all pairs of congruent angles in the diagram. So just like we talked about the tick marks show that segments are congruent, these arc marks show that the arcs are congruent. So the same arc marks mean that those angles are congruent. So in this case, you can see this single arc on P and N. So angle P is congruent to angle N. And then you see the double arcs with angle L and angle M. So those are congruent as well. Okay, so then we have an angle bisector. An angle bisector is a ray that divides an angle into two angles that are congruent. A ray that divides an angle into two congruent angles. A ray that divides an angle into two congruent angles. So in this case, this ray WY is dividing angle XWZ or ZWX into two congruent angles. Those two congruent angles then are XWY is congruent to YWZ. So in the diagram below, it says ray KM bisects angle LKN, and the measure of angle LKM is 78 degrees. Find the measure of angle LKN. Well, if I know that this side is 78 degrees, then I know that this side also has to be 78 degrees because I see these arcs that tell me that. So then I just have to do 78 plus 78 to get my answer, and I get 156 degrees. So the measure of angle LKN is 156 degrees. All right, guys, I will see you in class tomorrow. Have a great night.